Today we'll be working with our Unit 8 material on angles and arcs in circles. Our first piece that you need to know are these four formulas, and they all come from the location of the vertex. If you notice in our first one, the on the center for our central angle, that angle happens right in the middle. So whatever that angle is, that equals its arc. For our second one, if you notice, the angle is right on the circle. Anytime that the angle starts on the circle, it is 2 times that angle equals that arc. So here we need to find that angle by using the formula 2 times A equals 116. Then we just solve that algebraically. Our third type, we have whenever the angle is inside of the circle but not in the center, not on the circle. That formula, 2 times the angle equals the arc plus the arc, and the arcs come from whichever ones are opposite of it. So for this one we have the 70 and we have the 116. The final one is whenever it is outside. So similar to the one right above, this one is 2 times the angle, and this time it is the outside arc minus the inside arc. So those were our 4 types of angles that deal with the arcs in these circles. Our next piece that we're going to be working with is the segments. For the segments in circles, we have to worry about 3 different types of segments. We have our chord, our tangent, and our secant, and you need to know what each of these means. We have the definitions right in the middle there. For our first one, the 2 tangents. Whenever we have 2 tangents, so you see from B to A and from B to C we have 2 tangents, and in this one it's the easiest one. Tangent equals the tangent. So for this one, x equals 15. That's just simply BC is going to equal 15. For our second one, we have the 2 chords. Whenever you have the 2 chords, we need to identify the part times part equals part times part. For this, the part times part comes from the exact same chord. So here, that chord right there that is highlighted yellow, the part would be X, the other part would be 6. For the second one, it would be 2 and 9. And you are simply multiplying those together. So we would have the 9 times 2 equals 6 times x, which once you go and simplify through, you're going to get that x equals 3. The third one that we are working with is the 2 secants. Our secants, as you see, they enter from outside and going through our circle in 2 different spots. So for our secant, what you do is you identify the outside piece. So in our first secant, we have this 5 and 7. The 5 is on the outside, and then what you are going to do is it's going to be the 5 times the whole thing. So 5 plus 7 would be for the whole thing, and you could use your distributive property there. We have simply just made it 12 because 5 plus 7 is 12, and that's how we got our 60 here. For our second piece, if I switch this to green, our green highlight, we have 4 on the outside, which is where that 4 comes from, and then we have times the entire thing, the 4 plus y, which we will have to go through and distribute, which gives us the 4y plus 16. Whenever you go and multiply each piece, draw your little rainbows, make it happen. And we have our 4y equals 44 when you subtract the 16 over. Next we would divide this 4 on both sides and we get y equals 11. For our final segment in the circles, you need to identify what type of pieces that we have here. We have our secant and then we have our tangent. This formula, whenever you have both of these items, we do tangent times tangent. So it's tangent times itself. Notice it is not going to be the 8 times 4, it is the tangent by its own individual tangent, and that's why it is 8 times 8 equals in our secant formula that we just used in the previous example. the 4 on the outside times the whole thing, which is 4 times 4 plus z, or z plus 4. It does not matter what the order is. Moving on to our next page, let's do one example from each type. Main thing, like I said, in the first set of 4 formulas that we had, we need to identify where does the angle happen. In our first example, you see that it happens directly in the center. Whenever it happens directly in the center, what we have to do is take a look at whatever is given, either the angle or the arc, because that answer is going to be the angle equals the arc. That angle right here in the middle is 150 degrees. Now, these questions won't always be that easy. They will sometimes go and say, for instance, if I changed up number 2 and just put this here, and let's say that we made this one here be 95 degrees, and we were asked to find this arc. You would need to go and then remember how many degrees are in a circle. So we would have our 360 degrees in the entire circle, and then just subtract the 105 and the 95 to get the remaining amount, which should be 160 degrees, if I did the math in my head right. Moving on to a second example, our next piece here, we have our angle, which is on the circle. Whenever it is on the circle, it is 2 times the angle equals the arc. So we have 2x equals 170. From this point, we divide by 2 on both sides. When we divide by 2 on both sides, you should get x equals 85. In our next example, we have, for number 5, the angle is inside of the circle, but not in the center. For this type of question, you need to identify where the angles are happening. So here we have, this one is 126, and it really doesn't matter whether you say you're using angle N or the 126, because those are vertical angles, and when it is not in the center, it's 2 times that angle, which 2 times 126, and then, oh man, that's bad. Okay, so back for this example that I've fixed now by typing it, you have 2 times the angle equals the arc plus arc. So anytime it is in the circle but not in the center, that's the formula that you do. So then we would just go and solve this, multiply these first 2 together to get us 252, that's a 5, equals x plus 190. To finish solving this, we subtract the 190 on both sides, which gives us 62 degrees, and that equals x, which is our smaller arc in this situation. For the final one, this is where our angle is outside of the circle, and in this situation we are trying to find that angle. That formula will be 2 times that angle equals the outside arc minus the inside arc, which is that 155 minus that 91. So what you do to solve this, take out 155 minus the 91, which gives us 64 equals our 2x. Then we simply go and divide both sides by the 2, which gives us the x equals 32 degrees. For numbers 9 and 10, we need to identify where the angle is happening. For number 9, that's happening on the circle, so please remember that formula. For number 10, we have the angle happening outside of the circle, which for the outside of the circle, we know it's going to be 2 times that angle equals the outside arc minus the inside arc. So here you need to figure out what that outside arc that I just labeled in green is in order to solve that. For number 11 and 12, they're both set up the same way. We need to figure out those what the entire length is, which if you take a look there, that's going to be the hypotenuse. We know that that angle right here is a 90-degree angle because that circle is cut in half right there. That is the diameter of the circle, which means that this entire arc here is 180 degrees, and 2 times the angle right here equals the equals that arc. So 2 times this angle equals that arc of 180, which that means that that's going to be 90 degrees. So we simply use Pythagorean theorem to solve number 11 and 12. You just have to be smart about what it's asking. In that first one, number 11, it's asking you to find the hypotenuse, the whole thing. In number 12, it is simply asking you to find only the radius. When you do the Pythagorean theorem, you're going to find the whole thing, and you just need to figure out what to do with that radius at the end. For 13 and 14, this is where you are going to have to go and remember what tangent lines mean. So looking at number 13 here, we have this one tangent from this dot right here to the end is 8.7, which means this right here is also 8.7. So then you got to do a little bit of subtraction to figure out what the rest is. Whenever that's 8.7, that means the rest of this is going to be 7.1, which means that this one right here is going to be 7.1. To find the rest of that, we do 16.1 minus the 7.1, which will give us 9 right there, which means that this right here is also 9. Perimeter means we add up all of the sides. For the next two examples here, we have different ones. We are working with our segments in circles. We need to identify what type of segments that we have in each one of these. So right now, our problem here is asking us to find from B to A, so the length of B to A. But right here we have two secants. When you have your two secants, what you have to do is you have to take the outside times the whole thing. So that's going to be 9 times 9 plus 21 equals our other side of 10 times 10 plus the 4x minus 3. I'll clean that up for you in one second. So to finish this up, we need to combine some of our like terms. On the left side, we have 9 times 30. And on the right, we can combine the 10 and the negative 3, give us 10 times 4x plus 7. We will go and multiply on the left side to give us 270 equals on the right side. We're going to distribute, draw your little rainbows, make it easy for yourself. So we have 10 times 4x, which is 40x, and then plus 70. So as you see, this one's going to work out very nicely. We need to subtract 70 on both sides, which is going to give us 200 equals the 40x. And whenever we go and divide by that 40 on both sides here, we are going to get x equals 5. Now that would be great if that was our answer. However, we need to go and plug that back in. So we need to plug that back into the 4x. So 4 times the 5 right up here, which gives us 20. 20 minus 3 gives us our answer of 17. For our next problem here, number 16, we have two chords. The two chords are the segments that are inside of the circle that do not go through the center. What we have to do whenever we have two chords is basically you want to identify each one. So we have from U to W, which is what it wants us to find, and we see that that one is attached with the 6 and the x plus 2. The second chord that we have is from V to T, which I try to draw in yellow. We have the 12 and the 5. So for this one, for each one, it is part times part equals part times part. So on the left, we have 6 times x plus 2 equals the 5 times 12, or 12 times 5. It does not matter how you put it. To finish solving this, what we need to do is distribute on the left side. So we have the 6 times the x plus 2, so 6 times x is 6x, and then we have plus 12 equals, and then we just multiply on the right side to give us 60. At this point, what we're going to do is subtract the 12 to give us 48 equals 6x, which is going to work out nicely whenever we divide by 6 on both sides, and that's going to give us x equals 8, which we need to go and plug in for our u to w. U to w was 6 plus the x plus 2. Our x is now 8, so 8 plus 2. So we see here that we are going to get 16 for that answer. For our final example for these segments, we have our last one in number 17. We have a tangent line right here, which is attached with the 30, and then we have a secant line, which has the 18 and the x. So to set up this problem, what we have on the left side, we have the tangent times itself, so 30 times 30 equals the outside times the whole thing, which would be 18 plus the x. In order to solve this, our next piece that we need to do is we need to multiply on the left to give us 900. And on the right, whenever we multiply 18 times 18 for that first part of our distribution, we get 324 plus 18x. To keep going and solving this, now we just have a two-step equation. We need to subtract 324 from both sides. Whenever we subtract 324 from the 900, we're going to get 576 equals 18x. In our last step, we just divide by 18 on both sides to give us x equals, let's see, x equals 32. And that is our answer. At this point, you should be able to go and solve every other single problem that we have in this worksheet, except for the constructions, because you don't have one of those at home. You don't have the compass.